Uh, Hello. You can hear me. Thanks for joining this after lunch session. And let me first introduce Silvia. She's, how to say, the brightest data scientist I've ever worked with. And I'm really happy that we worked on this project.
Thanks, Diman. Thank you for joining us in this afternoon session. Diman is a senior engineer at Limplum. He's the most passionate specialist who wants to optimize every project and reduce the cost and make things better. And he also led this project that was for optimizing the user experience.
Okay, so how was the lunch? Are you sleepy? No, but well, it would be good if you're sleepy, because our first part of the presentation would be to start imagining some things. Let's imagine that we have a huge warehouse full of goods. We are rich, right? But also we have a tiny little problem that there are no customers, or there are just a few who consume the goods from our warehouse. Well, this is a problem, because imagine how expensive it is to maintain this warehouse. In the ideal situation, you will have a lot of customers enjoying your goods. And actually, our presentation today is not about restaurant, but how we managed to optimize or to improve 15 times the utilization of Limplum so-called virtual warehouse. So, but before we continue, let me tell you what is our warehouse, what are the goods that we put in there. How many of you use Tinder on their mobile apps, or good? Or for example, Mozilla or Opera browsers. So if you do, you're actually a client of Limplum, because what Limplum does is to provide their clients an SDK which is installed or integrated into the mobile applications. And then each click, tap, swipe, or whatever, every interaction the user does with with the customer's mobile app generates events that are ingested, actually first accepted by our infrastructure, then ingested into the storage. And these are just a few numbers, but all I can say is that Limplum monthly active users are more than Twitter, for example. So this is a huge flow of events. And what are we using these events for? Actually, Limplum is not using the events, but the marketers on the other end of the diagram would like to know how good is their marketing campaign, how are the results, can they optimize more so that they maximize the profit, for example. So, as you may already guessed, the goods in our warehouse are the reports. We are providing the marketers with analytical reports on how their marketing campaigns are going on. So to focus on the really simple view of the reporting process, the yellow guy there is the marketer. He sends a request to the report server. So first we check whether someone else has requested this or not. If not, this is the worst case. We go and query these petabytes of data so that we can put together the report that the marketer wants to. In order to, in a way, pre-warm the cache, we have a pre-computing cluster which more or less with a brute force approach calculates as many reports as possible. So our warehouse is full of reports. Ideally, the customers will benefit from it. But before we continue, let me tell you about the user base of Limplum. So it's spread on 4 continents, 17 time zones, but most importantly, they differ from culture and religion. The data volume that they generate, each customer, is quite different. You can compare Tinder to a much smaller app, let's say Expedia. But also the way the customers are using the tools Limplum provides differs. Some may have just very basic events traffic, but other can explore a lot more of the options. So the data cardinality also is quite big. So what do we have? A diverse user base, which also our users have very different usage patterns. So if we have a one-size-fits-them-all solution, we inevitably have to make a trade-offs. Trade-offs of performance, trade-off of ad hoc reports functionalities, which basically leads to some not very happy users, let's say unhappy customers. What we would like, and I suppose you also would like to have, is happy users. But we are in the situation where, in a classical situation with pick 2 out of 3. We cannot skip the constant data ingestion, just the data should be accepted and processed and ingested. What we can trade off is either latency or data freshness. In this project, actually, we tried to achieve all of these 3 so that our customers are happy. But when we started working on the project, we somehow ended into a crime scene. Unfortunately, the victim is the marketer. And our suspect is that, well, he died waiting for the reports to produce some data. But unfortunately, we only had some indirect clues like system loads, queue delays, log information, very basic observations. So we were not able to tell what actually is going on, what kind of reports the marketers do most often. That's why our first step in the project that we worked on is to do some instrumentation on the front-end and back-end components so that we understand better how our users are using the analytical tools. Are there recurring queries? This is an indicator that we should precompute more of these reports and do not precompute some other that are very rarely used, for example. How many reports have been abandoned? Why are they abandoned? Or what is the cost of the report in terms of latency, in terms of even a computational cost? And most importantly, why the performance is poor? So with this instrumentation, we hope to find answers to these questions. Well, this is how our architecture slightly evolved by recording each report, each query into a, well, in our case, in a big query in GCP, so that later we can do some analysis on the data. You, of course, can do it into a relational database, even if you like in CSV files. It's up to you. In our case, it was more convenient to use BigQuery. So just after going production with this change, we had immediate results well, actually Silvia spotted a few anomalies. I said, okay, this is not normal. This goes out of the classical usage patterns. And after listening to her, it appeared to be some bugs. So it is really important to work with someone who understands the data and can provide you insights on this. Well, then we hit this number. We are not very proud of it, but I have to tell you. This is actually the yellow thing. The circle is how many reports we precompute. The purple one is how many reports actually the marketers request, and in the intersection is 1.72%. It's quite small. So do you remember the empty tables on the second slide? Well, we are more or less in this situation. Still, well, the good news is that almost half of the user reports are pre-computed, but the ratio is quite bad. That's why, furthermore, we were able to find some different usage patterns. For example, when customers from Asia are mostly using analytical tools, when customers in North America are using this, what is the average length of report that they request? Again, split it or segmented by different geographical and maybe cultural criteria. And then we said, okay, this ratio is quite bad and we have to do something about it. That's why we came with the idea that we'll be smart. We'll precompute only what is needed. So we would like to predict actually what our marketers will request based on the data that we've collected. And our second goal, which is also quite important, is to reduce the operations cost in terms of what can we afford not to precompute, so that the users still get response for our reports quite fast, but we are cost saving, for example. And here I'll give the floor to Silvia, who will focus more on the machine learning approach that we've taken to achieve this 15 times optimization.
Okay, let's continue the story of optimizing customer experience with machine learning. We will start with the first step of the machine learning process. It's feature engineering. How many of you have actually extracted some features from data? Are there any? Okay, good. So probably the other ones don't know, but that's the largest part of the machine learning task. It takes most of the time. You have to look at some analytics, do some cleaning of data, also a lot of data transformations. But in our case, we have two entities we want to model. From one side, these are Limplom customers, as Diman said, marketers. And from the other side, these are the reports, the analytical reports they are using. There are a variety of metrics, a variety of analytics they are using. So we want to find more about the needs of the customers in order to know what kind of reports we have to prepare for them. To give you an example of how customers are using Limplom, I will list a few usages. For example, a large part of Limplom customers are in the mobile gaming industry, and they are using Limplom in order to optimize the gaming experience in the mobile games. So for example, if a game level is too hard or too easy for the users, they will spot this in the analytics, and then they can fix the game. Another part of Limplom users are marketers, and they are mainly focused on the impact of the campaigns they are creating. For example, they will look in the purchase events in response to some kind of push notification, email notification, or something like this. And also, as Diman mentioned Tinder, we have also dating applications also. And I'm not sure what they are focusing on exactly, but probably
A/B tests.
they want to keep the user base, I think, growing. And that's why probably they are not interested for you to find your best match. But that's another story. So that's their business, but our business is to provide them the reports they want, the insights they want very fast and when they need them. So we have two sources of information about our customers. This is the customer profile and the historical usage that we are already tracking. And we have different kinds of reports. So let's start with the features for the customers. What features do we have? Initially, when a customer comes to Limpum, we don't know much about how they will use analytics. That's the so-called cold start problem for machine learning for new users. But in Limpum case, it's not so bad because we have a customer profile. In this customer profile, we have information about the industry of the customer, the mobile app, what platforms it supports, which countries they operate in, and so on. We also know the total number of customers they have, the users of the application. Once they integrate the SDK, their mobile application SDK with Limpum, we also know that they want to track certain number of events, which type of events. So we have some more information. And finally, when they start using the analytics, we can also use the information to create some aggregated features that are how many reports they are using, which type of reports, which day of the week they are using them, and so on. So here, we plotted the correlation matrix of the features, just to illustrate the number of features there that we are using. But we wanted to be sure that this feature actually will describe our customers. So what we do is we performed some k-means clustering and explore the clusters so that to see whether these clusters are actually meaningful to us. And here we plotted also the 2D visualization of these clusters, which is done by dimensionality reduction. And we can see that actually these features are very meaningful, and actually these distant points here are our largest customers that are very different in total number of users, how they use analytics, and so on. So now we know that we have some useful features to describe our customers, and then we can go to the reports. The analytical reports, we apply the similar procedure here. We extract some features like the type of the report, whether it's for a campaign or for some user activity, what kind of filters the user have applied, and so on. And we again do some k-means clustering to see whether these clusters are really meaningful. And what we found is that actually these clusters illustrate, for example, messaging report that is for push notification reports. These are for lifecycle campaigns. These are some overview reports with some filters or something applied. Now that we have some useful feature, we have to go back to our initial task. We actually want to predict whether a certain report will be requested at a certain time by a certain customer. So we have to transform again our data. For each day of our training data, we join also all the customer aggregated data at this point of time, and also all kinds of reports. And at the end, we have a column that says whether this report was opened or not opened. And now we have constructed some classification problem. But there is one minor problem with our data, because there are many combinations of customers, dates, and all kinds of reports. So we have some unbalanced data set. We have a lot of negative examples of reports that are actually not requested by the users. That's not a big problem, but we have to be very careful how we interpret the results and how we evaluate which model is good and which not. Good practices in these cases is to start with some dummy classifiers. These are just some random classifiers that will give some random output, but we will present us with some baseline so we can improve over this baseline. We use two of them. The first one is most frequent dummy classifier. This one predicts always the most frequent value that is in the training dataset. In our case, this is the report not being requested. And it will be right in most of the cases. The other one, the stratified classifier, we predict again some random results, but it will respect the distribution of that there are more reports not requested and less reports requested. And finally, we go to the real models, and this table presents 4 models, the 2 dummy classifiers and 2 random forest classifiers. The first one, the most frequent classifier, has a pretty high accuracy of 92%, and that's pretty high accuracy, so most people would be happy with this accuracy. But on the other hand, all other metrics are 0, which is bad. I guess some of you are familiar with what are these metrics, precision, recall, and F1 score, but I will just explain in our case what's this. Recall, these are how many of the reports that are requested we actually detected. So, for example, yes, here is 0. The precision, on the other hand, would give us the intuition whether we are sure if a report, if we predict that a report will be requested, how sure we are that it will actually be requested. And F1 score is a combination of both that are above. So going to the next classifier, it has a bit lower accuracy, but it has some very minor values for precision and recall. That's because it should just randomly some of the correct values. So in 10%, for example, it detected that the report is requested, and it was actually requested, just randomly. So we want to perform better than these random classifiers, and we start with some random forest classifiers. The first one has a pretty high accuracy of 94%, but that's not so much better than the dummy classifiers. So we look at the other values. The recall here is about 50%, which is quite bad. It means that we detected or predicted that only half of the reports will be requested, and so we have only half of the reports already pre-computed in the cache, and the other half we actually missed. So we want to optimize this model, and we do this by with the next model here. That's especially optimized for recall. We do this by fine-tuning the parameters of this model. This is the depth of the trees, the number of the trees, and so on. And also by adjusting the threshold where we predict that the report will be requested or not. This is the probability, actually. And we achieved quite reasonable accuracy, but pretty high recall of about 90%. That means that about 90% of the reports that we predict that are will be requested are actually requested, and we only missed 10% of them. So 10% of the reports will be not pre-computed. The user will wait for the results to appear on the screen. We have to scale up the cluster, load the big data, and so on, which is not very pleasant for the customers. But for 90% is pretty good. In this case, the precision dropped a bit from here. What is the precision in this case? The precision is about 30%. That means that only 30% of what we predicted are actually about 70%, the other half, will be not requested. So we will pre-compute 70% more of the reports, which seems pretty bad, but remember we started with this number of 1.72. So now we have 30% of actually matching, and only 70% not requested. this is what we added to the previous schema. We added the machine learning service, and this is a monthly retraining service that will take the latest data of the usage of the reports, then retrain the model, save it, and then there is a serving part that will serve batch prediction to the pre-computer server service, and it will decide which of the reports to pre-compute and to have them preloaded in the cache. And this is the illustration of the improvement of the result compared to the previous one. You remember it was only about 2%. Now we have 30% of the reports pre-calculated.
Yeah, these are just numbers, but what does it mean for our customers? Just from September to October, we managed to improve twice the latency. Means our marketers are waiting two times less than before, and also by reducing the big yellow circle to this smaller one, we also reduced the computation cost, or actually the cost that we need to maintain the warehouse that we have. Still, you see, the intersection is now about 90%. What we would like to achieve is to move more the purple circle to overlap more with the yellow one, and also to minimize the yellow one. So it's still work in progress. These are quite good numbers, but they can be always better. As I said, I like to optimize things, and there's always place for improvement. Also, we have an idea of using more of usage patterns from our customers to calculate an optimal time when they are going to request a report, so that we can prepare it slightly in advance. I mean, do not precompute each report with each new portion of data, but only when or shortly before a customer actually requests this. So these are actually the outcomes of our project so far. We see a great potential in using machine learning in optimizing the user experience with the Limplum products, but I suppose you all worked with big data and you have more or less similar problems. So I hope this was useful for us. A wise man once told me that, well, too many messages kill the message. So if you have to walk away out of this presentation with a single message that we want to give you, let this be it. Do work with someone who knows how to work with data, and listen to the data scientists, because they, well, from software backend software engineer perspective view, we would not be able to achieve these results if we work only as a from the data point of view or from the backend point of view. That's why we joined forces and achieved this. So do work with data scientists who know how to work with data. Well, thank you. And we'll be happy to answer some questions more on the technical part, on the machine learning part as well. Just ask. Well, I can tell you about the instrumentation, what we did. As I said, there are two group of components that we want to instrument. One is the front end, and there you have quite a lot of options. For example, even you can use Google Analytics with the limitations of number of events and parameters that you can use. It's a kind of a JavaScript framework that you plug and you start tracking events. Having a solution like a do-it-yourself instrumentation in the front end is quite expensive, not very reasonable, because it's not really part of your business logic of the application. You just add or patch the code so that you can track. That's why my suggestion is to use something especially designed for this. We've been lucky that Limplum has this kind of tracking SDK also for web applications. So we instrumented our own analytics with the Limplum SDK, so we were able to track. Now on the backend side, however, we wanted to track like telemetrics. How is the heap used? What is the CPU usage? Are we swapping on the disks? Things like this. Execution parameters. How long does it take to execute a query on Spark? Why is it slow? Do we have a cache hit or miss? What is the cache hit ratio? And so on. And most importantly, this you have to model yourself, is the features of the requests that the user sends. In our case, reports have more than 40 dimensions, so we are collecting them all. So in this case, we really did do-it-yourself solution, even if I don't like it, but there's no out-of-the-box solution for this. And all this data we collect with each request and store it in a BigQuery. It's kind of hierarchical data that you can easily query, slice and dice and do analysis on this. So I suppose every relational database would suffice as well. And more details on the machine learning part.
I guess the message is the same. You have to do it custom for the custom problem.
As simple as that.
Yeah.
It's more of the data science part of things. So why did you decide to optimize for recall and not precision?
Because for us, the most interesting...
the question is why we optimize the final model for recall and not for precision.
Because in our case, we want to optimize the user experience. And in our case, the user experience is the report to be delivered fast. So it should be detected and already in the cache for the customer. So we want as many as possible of the requests actually detected. And of course, there is a trade-off, and the precision will drop, and we will pre-compute some more reports. But actually, because we are starting from this point that we pre-compute almost everything, based on some rules, of course, but almost everything. So we just have some significant improvement over this.
Yes, please.
Hi. First of all, congratulations. This seems like really very good results. Basically, when deal with customer data, the main concern is data privacy. So how do you handle it?
Well, we actually had a slide about GDPR, and we removed it because we are not experts. However, I can assure that Limplum is GDPR compliant, and that's it. I mean, really, I'm not a specialist to tell you, but we've been assured by our lawyers and so on that we are compliant with the GDPR. I know the problem of GDPR and machine learning. For example, all our marketers allowed us to use their usage data so that we can model and make their experience better. And also, we actually do not care who the user is. We do not have user IDs or emails or so on. It's just a user from Malaysia, for example. And
but just a second, but based on his preference, you could identify him, right? Or her?
Yes, that's why they agreed on this. But I wouldn't, of course, do it. And as I said, we are not GDPR experts here. I suppose a GDPR lection or presentation would be quite useful in this case as well.
Okay, thank you.
Hi, thanks for the presentation. I have a question like this. If you know what reports people are asking for, why do you really need the machine learning? Can't you just prepare the reports that people are asking for?
That's a good question, actually. We have a concept of bookmarks at Limpom, so people can bookmark their reports. But unfortunately, they rarely use this feature. So,
Well, we
yes.
actually do not really know whether they're going to use the same type of report after a day or two. It very much depends on the environment, what kind of marketing campaigns they're running at the moment, which of them has finished. And also one of the slides before we presented kind of usage patterns, how often after a given marketing campaign finishes, the marketers start seeking for results from this campaign. So we have kind of a snapshot at a given point, but we do not know whether this report will be requested again with different dates or with slightly changed parameters. That's why we created kind of a query fingerprint so that we find recurring events, and also grouped the different reports into, I think, 7 clusters based on their recency and also the number of occurrences in our data set. And we started precomputing the first 2 clusters only. By actually, how the precomputing work, maybe I have to focus on this a little bit in the presentation. When the new data comes, it's like 1 million events for a given application comes at a given period of time. We say, okay, let's see what reports we need to precompute. We cannot reverse engineer to know these events will be used in these events. It's an NP problem. But that's why we need this machine learning approach to actually predict what reports will be, in a way, affected by the new data that have come.
I think I understand what you're saying.
Okay, thank you.
Thank you.
Well, any
No
other
more
questions? We are almost on time. Thank you.
Thank you.